So hi everyone, my name is Summer Sherman-Bertinetti and I'm coming from Clean Water Services down in Oregon. And today I will be talking about identifying the dominant sources of PFAS to water resource recovery facilities or wastewater treatment plants using a mass balanced approach. So I'm going to start the talk just with a little of who we are. So Clean Water Services, we are a water resource management utility. So we do resource recovery or wastewater, and then surface water management, aka stormwater. We also do water security and planning and river flow management for the Tualatin River. So our watershed is we service 600,000 plus residents, and we have a watershed base permit, which was in 2004, the first NPDES permit, which combined all of our treatment plants and stormwater under one watershed base permit. So we have four wastewater treatment plants, which two of them service a lot of large industries, while the other two are more commercial and ag. And we also service about 1/3 agricultural. And we are very focused in keeping the Tualatin River as clean as possible because we do discharge to it to keep the river flow managed. And so this river is a salmon bearing river, which emerging contaminants can have a large issue with. And so in general, why do we care? There's a lot of rules, of course, that come up, but in general, the main reason is that we utilize science and nature to clean water and return it to the Tualatin River. And so we work in partnership with others to protect the river's health and viability and just, to protect the public health. And so in 1970, this is kind of a picture from 1970 prior to Clean Water Services forming. That thing, right, the river right in the middle, that is the Tualatin River. And so back in the 1970s, this river was extremely polluted and very choked. And so in the 1970s, Clean Water was formed under a previous name. And in addition to wastewater treatment, we began managing the river, managing the stormwater and the flow of the river. And so today, this is kind of what the river looks like now. And so in 2023, and I know there's more recent information that came out, within the last couple weeks, but in 2023, EPA announced this plan for wastewater regulations and studies, which includes limits for PFAS. And so, other than caring for the river and public health and all the organisms within the river, we also, care about the upcoming regulations, and we would like to get ahead of them and hopefully influence kind of the legislation in some way. And so wastewater treatment plants in general, they don't really create any PFAS. We take a lot of inputs from a lot of different places. I know in the PFAS realm, this image in particular is used a lot. But we get industrial discharges from landfill leachate, community and domestic discharges. And from there, we either discharge to the river, utilize the water for reuse, or in biosolid applications on the land. And so we really want to understand first kind of like what the concentrations are at our facilities, and then also understand what is coming to us so that we can understand what is going out and how we can start these source control parameters prior to any legislation, just for the public health and the benefit of our river. And so for the purposes of our talk, I kind of just highlighted this talk will just be about things coming to the wastewater treatment plants and not discharging afterwards. And so I kind of want to start with PFAS concentrations at our 4 treatment plants. And so on the y-axis, we have PFAS concentrations, and on the x-axis, we have increasing carbon chain length. And so the red and blue are both our aqueous, so they're the influent, effluent. So I'll just first start with that. In general, the red and blue bars, aka or influent, effluent, are very similar, throughout every single compound. Yes, there are a couple compounds that there are some differences, but in general, you can see that what comes in is mainly what comes out. And there are some, like PFHXA, that the effluent has slightly higher concentrations of the influent, and this could, possibly be the breakdown of precursors throughout the treatment processes. The other thing to note is that in general, there is kind of a trend of shorter chains being higher in concentration. And as we move to longer chains, there is a decrease in concentration. Of course, PFHXA, PFOA, and PFOS are a lot higher than a lot of the other compounds, but this is probably due to their main use as the legacy compounds. And now, as the shorter chains are becoming more prevalent, we're seeing a greater increase, more prevalent. But we know in general, shorter chains prefer the aqueous, while longer chains prefer to partition to the solid phase. So if we look at this black bar, which represents our biosolid concentrations, we kind of see the opposite trend, where there's a kind of a decrease, or there's a lower concentration at the shorter chains with a higher proportion of PFAS that are longer chain partitioning to the biosolids. And so we kind of wanted to put this into context of, we know what is at our wastewater, but how are we doing compared to the national average? And so each color here is one of our 4 treatment plants, while both the gray and black are the concentrations of the nationwide average with industries and without industrial impact. And so in general, for almost all these PFAS, except for PFBA, at one of our or a couple of the shorter chains at one facility, we are below the national average for these compounds in general. PFBA and PFBS at one of our treatment plants is a little bit higher than the national average, but this treatment plant, the Rock Creek treatment plant, is industrial impacted. We have a lot of industries discharging here, which we could probably postulate that this is the reason why we see a higher increase. So we also kind of want to look at, how does this look with our biosolids? And so again, the 2 colors represent our wastewater treatment plants, while the gray and black are the nationwide averages. And so in this bottom right figure, we do see for PFOS and PFOA, we are below the nationwide averages, regardless if it was industrial impacted or not. However, these industries, if there is a high impact on biosolids, it can really skew the distribution. And so this top figure on top really shows that, this average is a lot higher, but it would be best to possibly look at the median. And so if we look at the median for PFOS, given our concentrations, we are basically at what nationwide the normal wastewater treatment plant would be. And so now that we kind of know what is at our treatment plant, we want to understand what is coming to us that is giving us these concentrations. And so we wanted to look at PFAS concentrations by these wet industries. And so we have a bunch of different wet industries here. And, you could see in general, the electronic component, metal finishing, and rubber manufacture are a lot larger than the rest of them. And all of them have different PFAS that relate to the processes that they use. And also I want to note these error bars in general for the electronic components, the error bars are a lot smaller, which shows that the PFAS are coming from the same processes each time, while metal finishing is more of a job shop where there is variability. And so if we just look at the electronic sector, we see a wide range of concentrations. However, the distribution of PFAS that we see is generally the same across the board, again, showing that it is coming from very similar process. Metal finishers, like I said before, they're more job shops, and so they have a wide range of concentrations all around. So each color is a different PFAS that is in there. And also they really range in concentration. For instance, this bottom figure is from 0 to 400, while one metal finisher had PFAS levels that were around 15,000. The total PFAS concentration was around 15,000 ppt. We also wanted to look at, what are the concentrations in commercial and domestic areas. So we were able to utilize the sewershed, utilizing the manholes that were single sector by contributing land use, and see what these contributions are. So if we look at the PFAS concentrations, you can see that the commercial and industrial locations, I apologize. Yeah, the commercial and industrial concentrations were in general higher than the domestic. Of course, there is this PFPEA that was the exception. And so I want to revisit this figure that we showed in the beginning, because, we have the concentrations coming to us. We understand what is coming to us, what our concentrations are, but now we want to look at source control effects. So if we just are looking at concentration, our first instinct would be to, have source control for the rubber manufacturer or metal finisher. However, the loadings to the wastewater treatment plants can be very different. And so though this electronic component looks a lot smaller than the rest, the flow that we receive from this sector is much larger, which can contribute to a larger proportion of PFAS mass coming to us from that sector. So we wanted to look at this in terms of a mass balance, which is kind of what I'm showing here. So this is total PFAS mass flux. So it's the amount of PFAS we are getting per day. And then the 4 sections are our 4 treatment plants. So Forest Grove and Hillsborough are mainly our domestic and non-domestic, so the blue and orange sectors, while Rock Creek and Durham, which have other colors, are our other wet industries. So I will first focus on Rock Creek. And so if we notice here, we have this black, which is a large semiconductor. We were able to go and apply source control efforts. And with talking with them, this major semiconductor installed treatment, and in general, their PFAS mass basically fell away. The next up is this yellow, which is the landfill. This landfill had a different issue, and so they had to stop discharging. So we could see, they completely went away. And we allowed them to come back without external leachate. And so we see that they come back at a smaller fraction. For our other treatment plant, we have this large red, which is this metal finisher campus, semiconductor metal finisher campus. When we were able to track down the spike of PFAS from them, which was mainly PFOA, we identified the source, and by chatting with them, they have been able to reduce that. And so we were really able to show that these source control efforts, by looking at the mass balance, are effective. And so for future directions, we want to track PFAS concentrations throughout the facilities. Right now, we're just looking what comes in and what would come out and be discharged directly either to the river or reuse, or biosolids that are land applied. We also want to track PFAS throughout the sewer shed and continue to monitor a lot of these industries and add additional monitoring depending on literature, such as, we didn't look at food packaging facilities, so that we can improve the mass balance and really target our efforts. So a lot has been done, but there's a lot more that we want to do. And so this was a huge team of people that have been working on this. I just kind of want to acknowledge them and, demonstrate it's not just a singular effort. And with that, I will take any questions.
Yes, we do have a couple minutes for questions. So,
we have one here in the Zoom. It says, are there any factories required to pre-treat their wastewater in OR before discharging to municipal facilities?
Currently, there is not. We are in discussions with, for instance, like the landfill to put in treatment. The large semiconductor industry, they were not required to put in treatment. They just knew, when we discussed with them, they just knew that's where the legislation was coming, and they actually took the initiative to do that. But as of right now, there has not been any, since a lot of these industries discharging to us are under our permit. We are actually putting in PFAS management plans in their current permit so that they will have to hit target PFAS prior to legislation coming to Oregon.
We do have a few more, Beth. Do we have time for those?
we can do one more, and then if you're willing to type out answers in the Q&A
Sure.
after, yeah.
Yeah, more than happy.
Okay, great. So I'll just read the next one that we have here, and then you can follow up with the others. The next one says, what was your method for getting the polluters you showed to decrease their PFAS contribution? Is litigation the only thing that holds them accountable, or are there other mechanisms?
So we do have they're called environmental services, and they are the ones who have gone out to industries and discussed with them. In general, like for instance, that I just said, people seem to be very receptive to, we've been sampling them, and they have not been, paying for this sampling efforts. We've been showing them the data that we've been collecting, and then trying to get them to understand where it is, where legislation is coming so that they hopefully, install treatment or at least understand what is coming out from their discharges. So as of right now, there's nothing in general. It's just they know where legislation is coming. But now with these PFAS management plans going into their permit, they now will be more enforceable for them prior to just state legislation.
Great, thank you.